Hey, everybody. Good morning, good afternoon, good night, wherever you might be at in the world. And hey, welcome to another one of our webinars. My name is Mark Schonagel from Autodesk, of course. And what we're going to look at today is Softimage, my product, as you all know. And we're going to look at that in the context of ICE, the visual programming language that, of course, is found only inside of Softimage. What is ICE? Well, as I mentioned, it's a visual programming language. It allows you to create stunning visual effects, deformations, modeling commands now with 2012 kinematics, so you can do rigging, all sorts of fun stuff found within ICE, and it all uses these nodes to create your effect. It's a full-on programming language, just like I mentioned, just like you'd have C or any of the other programming languages out there. We have ICE. The great thing about ICE is it's so much faster than C unless you're able to code in multi-threaded, because of course ICE is multi-threaded, and I'll show you that in a minute. What I'm doing now is just showing off a little rendering that I did. I used ICE to create this kind of a cool mousetrap simulation. If you actually go on YouTube and just YouTube Softimage and Lagoa, you'll find some of these animations on my YouTube channel. But just a quick little look at very high particle count scene rendering this with Arnold. There's actually about 2.5 million particles on the screen right now, all getting smacked by this bar here, the mousetrap thing. So anyway, just one of the things you can do with particles. Let me move on, show you another scene here that was created with ICE before we actually dive into the main part of the demo. So I'll just go here and let's just load up another couple scenes here. This one's actually graciously given to me by my buddy Paul Smith from the UK, who's been creating some very cool Softimage tutorials, and I'll whip up his website here in just a second. And what the scene is, it's a very cool little crowd simulation. Actually, it does quite a bit more than that. You've got, you can see these little characters all running around. They'll get more spread out here in a minute. This apparently is the sports shop, and they can purchase things like golf clubs, and then they can go around and hack at people. Zombies get spawned. These zombies come around and watch if they touch a guy. Watch, oh, they turn, they die. This is all being controlled, all being triggered with ICE. I'll show you a little bit where you can find more information on this scene, but again, something completely different than what we just saw with that other particle simulation. Each one of these characters is on a particle. They're all moving around, all with their own logic, obstacle avoidance, all kinds of stuff, all being programmed with ICE. Another thing I can show you created with ICE. With 2011, we introduced ICE kinematics, which allows you to do all of your rigging. So here we have just an awesome rig built by Phil Taylor, and it behaves just like a normal rig does. It has all the control that you'd expect to find in a rig. If we move here to a different frame to start the simulation, I can start to move things like the head, and you can see we've got secondary animation going on there with the ears. There's the belly's moving. All this stuff, as you can see, we got some jiggle there in the belly. But the neat thing about this entire rig is built with ICE, and that actually means that not a single IK, FK, any type of a solver is actually on the character of the rabbit here. In fact, this entire ICE tree, which contains every single thing that makes that character move, is on an object that's not even part of the hierarchy. It's all on this object right here. So that means you can have rigs that are literally unbreakable because nothing actually lives on the rig. It all lives somewhere else and is all explicitly programmed. Animators can't break anything. What's also neat is you can just go in and replace components. Like if you wanted a different tail behavior or different spine behavior, just disconnect the old spine, reconnect something new that maybe has a little different logic into it. And again, your animators can't break this. Another thing that's amazing is to be able to really boil down or almost compile a rig. If you look at this right now, you can see a massive hierarchy. A lot of the objects are hidden, and a lot of these are just the deformers, the bones or things that are actually driving the rig, constraints, some of the different icons. Well, because the rig isn't on the actual character, you can strip all this stuff down. You can actually load all this into a cache. I'll show you how we can do geometry caching later in the demo. But you can essentially compile a rig by taking all the parameters, all the data, the location of all the deformers, the weighting information, offline that onto a separate object, onto a separate cache rather. And if I go ahead and load up this version of the rig, the same exact character, watch this. We'll go and stick this into hidden line real quick. If I open up my schematic check this out. This exact same rig, only these are now the control objects because everything else has been stripped off and compiled, baked down, because ICE will allow you to do that. ICE will allow you to work with caches. And this rig actually performs now about twice as fast as it did before we did all that. So not only is it now completely locked down, but it's also operates much faster. So, again, just another cool thing you can do with ICE. Won't talk too much about rigging today, but you can definitely do some very neat rigging stuff. So let me just move on to one more example. And this is one of my favorite examples. This is actually done, I think when ICE was still in beta, version 1, by my friend Andreas Gephardt. And he thought, well, we can shoot all these particles, and particles can have strands, so shoot, why not make a ray tracer? So check this out. This is a particle ray tracer all being created with ICE. There's all the rays escaping. But if we take a look through the camera, watch this. You slide this slider, and he's basically built a ray tracer out of ICE. And I might actually show you another example of this in a second. But you can move everything around. You can move if I grab the screen here, I can move that around just like you would have a real screen. And, it's a ray tracer just built completely through ICE using by shooting a bunch of particles. So let me see. Maybe I'll show you one other example of something interesting you can do before we get on to the demo. Yeah, here's a nice example of a deformer rather. So go into this guy, and most of the math, most of the work is being done inside of this one. Dual quaternion skinning. Some of you may have heard about it. Check it out. All sorts of nodes. What was cool about this one's been around for a little while too, but this was actually done within 24 hours of one of our engineers watching a SIGGRAPH paper on the math and technology behind dual quaternion skinning. He had actually come up and created a prototype of this tool within ICE without a single line of code being written. So check it out. There's dual quaternions, and all created through ICE. So we're taking the standard Softimage enveloping tools and extending them to use dual quaternions, all using this node-based system. So I'm going to go ahead and get a new scene here, and let's go and get into the demo. But first, let's just get a word from our sponsors. So here's a nice slide from our sponsor today, HP, just showing you how their product family pairs up with some of the Autodesk products. In my opinion, the Z800, the Z600 are just two awesome workstations for Softimage, for any of the 3D products really, which I have the most experience in. The Z800 is just an awesome machine. Very powerful, very well designed. Really, ICE, because it's multi-threaded, you really want as many cores as you can. So like a 12-core workstation you can get with the Z800, the Z600, and the Z400 is fine too if you're doing some kind of some smaller projects where you don't need quite so much RAM, you don't need quite the beefy graphics card or as many CPUs. So anyway, all of this stuff is certified for all of our products. So if you're buying something from HP for any of our M&E products, it's going to work a-okay. So with that, let's go ahead and let's start the demo off. All right, well, now that we've seen a few different examples of some of the things you can do with ICE, let me show you how it's all put together, how we string those nodes together, those compounds together, and actually create a desired effect. One of the first things I'll do is just set up my user interface. I'm going to go ahead and turn on my main shelf here under View Optional Panels Main Shelf. And what that does is just exposes these different tabs, which will allow you to create primitives, just navigate a little more. That's kind of like the way Max and Maya work, so for you users, it might make a little bit more sense. I'm also going to show you the keyboard mapping here real quick. I won't change it, but again, if you are coming from Max or Maya, you might want to go into the keyboard mapping and choose the appropriate hotkey setup. I recommend, though, if you're going to stay within Softimage, use a Softimage key map. And when I refer to hotkeys, I'm going to refer to the Softimage keyboard mapping. But again, if you're using Max or Maya, it might make it a little bit easier for you to navigate inside of Soft. So once we're done with that, make sure you're in the ICE module. The modules in Softimage, easy to get to them. Just press 1, 2, 3, or 4, which will bring up Model, Animate, Render, Formulate, Simulate. Now it's the new ICE module. And all this really does is change the tools here on the left and gives you this little color highlighting to let you know what module you're in. With the ICE module active, click on this button down here in the bottom left. And what that'll do is set up the user interface to be kind of in what I like to think of like the ICE flow or ICE workflow environment. So here you got our ICE tree at the bottom, a camera, and then our Explorer. And I can move position these around a little bit if I'd like. I'm going to start off by getting a torus, and I'll just go into my primitives tab, click on torus, and I now get this primitive here in the center of my world. I can increase or decrease the subdivisions, maybe set this to like 10 by 10 or 1 by 10. Let's set that to 10. There we go, and start to do my work. Now, everything in Softimage is an operator as far as tools that you use. So if I open up my construction history, we can see I've got my polygon mesh, and then this node right here is what actually generated the geometry. If I were to simply move a point, you can see it logs or creates a move component operator. If I were to go and add a deformation, so I'll go here to my model deform, I'll add a, you can see there's a whole bunch of them here. I'll choose my push deformer, and you can see that adds the push operator to my construction history, and now I have the push effect on my torus there. Everything that you do in Softimage is an operator. And what ICE essentially allows you to do, especially when you're working with deformers, modeling, things like that, is actually create your own programmable operator. So instead of this being C++ compiled code, we're going to use ICE nodes to create the same effect. And that is what I want to create in this example, is just reproduce this push operator. The neat thing about having this operator environment is you can reorder the stack. You can delete certain operators. So there I just deleted the move component operator. I'm going to switch over to hidden line really quick just to see that a little bit differently. Getting back to this push operator, though, you can see that what this has is a few UI options. It's got our amplitude slider here. It's got a mute button, and it also has this hook, which will allow me to connect it to a weight map. And I'm going to reproduce all that within ICE. And I also want to show you how we can log a menu. So, under deform here, we've got all of these different deformers. I want to be able to add the tool that I create with ICE actually to this menu as well. And I'll show you how we do all that. So first, let's start off and just quickly build our effect. So with our object selected, I'm going to go create ICE tree. And you can see that now adds an operator here called ICE tree. I could right click and rename this to anything I want. I'll just keep it ICE tree for now. And let's actually go and delete our push operator that I put on there before, because again, I'm going to recreate that push operator using ICE. The way the push operator works, incidentally, is if we go and turn on our normals here under this little icon, the little eyeball icon here, let's turn on normals. And if we select our object, you can see these little blue lines. These blue lines represent the normal. The normal is just simply the direction or the vector that a particular vertice is facing. I'll turn those off. So I'm going to gain access to those normal values, and I'm going to push them along that value with basically a factor slider. So to recreate all that, I'm just going to use a few different nodes within ICE. So again, we've already created our ICE tree. I guess one of the first things, especially when you're working with deformers, is that you want to gain control of the vertices. So what I'm going to do is get a set data node, and I'm just going to drag that out. Now I typed in set data here. Well, what did that really do? Well, let's just back up a bit. You can see here that there's all of these different nodes and compounds. A node is simply a low-level node or a function, like a cosine here is just a node. But then we also have compounds. Like if I go into the law of cosines, you can see that here we have a bunch of nodes operating together to create one effect, and that's called a compound. And you can tell the difference very easily. A compound has this little E over it, which means that you can dive in and essentially explore it or edit it. And it also has this double line around it, which you won't see on a low-level function. So anyway, I'm going to go ahead and just delete that and take a look at some of these other nodes. You can see we've got a whole bunch of them here. Now again, ICE is a visual programming language. It has all of the logic, if-then statements, execution statements, things like that. Everything you'd expect to find in a programming language is in here, plus then also specialized tools just for doing 3D. And that's what I'm going to try to show you all today. So again, I was mentioning that we need to gain control of all of our vertices. So to do that, we're going to use a set data node and a get data node. The set data node, I'm just going to plug right into the first port. Within ICE, you have these different ports, and these ports get executed every frame in order. I'm primarily, for this deformer, just going to work with port 1, which is fine. But just keep in mind, every frame, these get executed in order. So set data, what does that do? Well, I'm going to double-click on it, and it's asking me, what data do I want to set? So I'm going to click on the Explore button, and this will bring up the Scene Explorer, and now I can just navigate and find exactly what it is I'm looking to set. So I'm looking to set the point position for all of those vertices, and wow, it looked like my torus just disappeared. Well, it didn't disappear, it actually collapsed onto itself because I essentially with this node set the point position of the torus to 0, 0, 0, and that affected every single one of the vertices. So this torus is now popped together as a little tiny dot. Let's go ahead and get our get data node, and I'll just do an explore on that as well. So explore, I'll get the exact same data, in this case the point position, and I can just close both these up. You can see this now turns blue, plug this in, and now I get my torus back. And the reason for that is really what we've done is essentially we've gotten the position of all the vertices, and this happened before we set them. So that's why it basically snapped back to the way it looked. And what this really did is it introduced this data workflow, this data flow. If I click on show values here, I can turn this to something like numeric, click OK, and check it out. Now we can see the numeric representation of every single vertice on this torus, which is cool. And all of that is being piped through this little yellow node. From there, I can now manipulate these nodes and kind of modify where all these vertices are. So, one of the first things maybe I'll do is just get the add node, and I'll just drag this out and drop it right on the yellow line. You can see that when my mouse hovers on that white line, or that yellow line, it turns white. That lets you know it's going to insert it like that, and you don't actually have to manually connect those together. Now if I right click on here and do a show values, there's all my values again, my vertice values. But watch this, if I double click on add, I can now add to every single one of these vertices the same value and say y, like that. And notice that all the middle values are changing as I scrub here. Here's a neat little tip for those of you that didn't know. A lot of times when you're moving these sliders, and look, I'm moving that slider like 1 pixel, and it's changing the value by like about 0.5, which is really quite a bit too much. So if you hold down the shift key while you move any slider within Softimage, it puts it into like a precision mode. So you can see that now, look, I'm moving my mouse, many pixels, and it's moving those in a nice smooth way. So any dialog box, hold down the shift and then start to click and slide, and you'll go into this nice precision mode. So I use that quite a bit, just a good little tip to know. Anyway, let's go ahead and hide our values there. And let's go ahead and continue working on our push operator. We're actually almost there, believe it or not. Let's get a multiply node, multiply by scalar. You remember from the original push deformer, it did have a slider. Anytime you need a slider, just get a multiply by scalar, and that'll let you essentially, basically the easy way of getting a slider there. So now the last thing I need to do is, because if I open this up, let's put a 1 in here and a 1 there. Now it's going to move 1 times x, 1 times y, and 0 times z for all the vertices. So if I move this now, you can see that the torus appears to be moving in x and y, but in reality, it's just each one of those vertices are moving. But what I want to do is give each one of the vertices a unique value to multiply by. And so for that, I'm going to get the point normal. So we'll do another get data. And I can plug this in right now if I like. You can see it comes up yellow, meaning, hey, this isn't right. You haven't given it all the data that it needs. So what I'll do is just double click here, and I will explore my polymesh, and I will get my point normal. So now this node represents each one of those blue lines that I showed you earlier. They're vectors. Double click on our multiply by scalar node, and we should have a slider that essentially pushes our normals out, just like the original push deformer did. So check that out. Essentially recreated the push deformer with just a few nodes. I've kind of done this before. Some of you might have seen this, so don't worry, we'll move on to some more exciting stuff here in a second, but just a quick little way of recreating this deformation. Now, I want to be able to use this tool on any object that I create in the future. Right now, this is only going to work on something called a torus. So if I were to put this effect on a sphere, that wouldn't work so well. So let me show you how we can bundle this up into a compound and actually register this as a tool that'll work on any object in our scene. So I'll just close this up real quick. I'm going to grab all of these nodes, right click, and say create compound. Look at that. It takes all of those nodes and essentially just dumps them into this container like this. If I press Control R, that's going to refresh and kind of tidy up my ice tree here. Double click on the compound, and you can see that the dialog box that comes up is completely blank. So let's go dive into our compound and reveal to the outside world the parameters that we need to make our tool functional. So in this case, the only parameter, the only thing that's really important for the push operator is the factor slider, right? So I'm going to take this little black dot and connect it to the factor slider, or the factor input, and look at this. Now if I leave my compound node, look, factor is now exposed. Double click on the compound node now, and check it out. My one and only parameter that's important for this tool is now been exposed to the outside world. Perfect. So now we can go in here and do a few other things. I had mentioned before that this was only going to work on an object called torus. So I need to change this so that'll work on any object. I could go in here and just type the word self or this and replace this, the word torus, or I can do this all automatically with a user tool. So click on user tools and click on this option right here, replace object name with self, and check that out. Everything that said torus specifically is now set to self. The cool thing about self is it'll work on anything itself, whatever object it is that it's attached to, it's going to work. So I'll go ahead now and close this up. Actually, let's give this a name really quick. Let's call this ice push. and I'll put it in a category called Marks Tools. And now what I'll do is close this guy up. And now we've got an operator called ice push. And if I just now click on export compound, this will allow me to save this to disk. And now this will actually appear in my list here as an available tool. So if I get rid of all this, type in ice push, there it is, ice push under Marks Tools. And now I can easily add that to any ice tree that I create in the future. Now the last thing I'll want to do though is actually add this to my pull down list. Remember I showed you here we have our deform list. Well, I want my new push to actually be right here inside. So watch this. What we'll do is just go to user tools and I'll just say add operator to menu. And then all you need to do is type in the name of the appropriate compound that you've created and tell it which pull down you want it to be in. I want this to be under deforms. So I'm just going to put ice push and close this up, close this up. I can actually delete this if I want, get another torus, get another whatever. Now if I go to model, deform, there's our ice push that we added to the operator, and check it out. Now I've got my push on this torus here. I could delete this. Let's get something here like a character. Let's get XSI man. And we'll just take this dude, grab him, and we'll do the exact same thing. Model, deform, ice push, and there you go. So now you can see we've got the Stay Puft Marshmallow Man. So pretty cool. Obviously easy to deploy these tools, use them further. And let me show you, we create that tool pretty quick, but let me really show you the real power of ice. Let's crank this up to like 200 by 200 subdivisions. And I'm just going to back out a little bit. Let's go put the deformer that ships with Softimage, the good old push deformer. So here it is. We'll put this on. At frame 0, we'll set an amplitude of 0. We'll go here to frame 100, set an amplitude of 2, set a keyframe there. And I'm just going to press play, and let's go and get our frame rate up. So this tool, this compiled C++ push operator is going at 49.9 frames per second, so about 50 frames per second. All right, let's go ahead and stop that, and let's delete the compiled push operator. And now let's go and grab our ice push operator that we just created and stick that on there like so. And now if I scrub this, okay, that's on there good. Let's set it the exact same keyframe at 0 and 2. Now watch, close this guy up and press play. Wow, 150 frames per second. So from 50 frames a second to 150 frames a second using a few little nodes that we collapsed down into a compound. Pretty amazing. I'm actually going to pop up here. I've got in Notepad, I've got the actual push operator right here. This is all the code that was required to create the original C++ push operator. Look at that. Crazy amounts of code. This right here just creates the dialog box. Just that slider with the mute button requires all of this code. So really, I mean, the benefit for ICE is massive. You get a fully multi-threaded environment. With 1, 2, 3, 4, 5 nodes, we created something that took hundreds of lines of code originally and executes a heck of a lot faster. The more CPUs you have, the faster this is going to execute. I'm in an 8-core workstation right now. The more we had, the faster that would get. And it doesn't scale linearly, especially for deformers, but you do see a very nice improvement as you start adding cores. So that's pretty cool, of course. And you know what? Let's do one other thing. Let's go ahead and just delete all of that. Let's go into Maya really quick, and I want to show you how we can bring a deformer in from Maya. So I'm going to create a torus, and I'm going to use my marvelous skills of Maya here to create this torus. We'll just set it something like that. And now normally with Soft, we have this one-click workflow between Softimage and Maya for ice particle effects. It doesn't quite work the same for deformers. We can easily send stuff to Softimage. So I'm going to send this scene to Soft, and I'll just say update the current scene. And now this brought in that torus from Maya, and you can see it's called ptorus, which is the Maya naming convention. I'm going to go and put the same deformer on there, the ice push deformer, like so. And now you can see that that's nicely attached. But I want to increase the functionality of this a little bit. So you remember in the other one we had the mute icon, and we were also able to hook it up to a weight map. I want to show you how we could do that with ice as well. So one of the first things I'll do is just go ahead and add that mute operator, that mute condition. So let's go into the compound. And I mentioned ICE is a programming language, so of course it should have if-then statements, things like that. So I'm just going to grab this if node, and I'm going to tell it that if this condition is true, meaning that it's checked, I want it to do the deform. So I'm going to bring this way over here, and we'll pipe this into the true statement. So execute all of this code if the condition is true, and I'm going to output the same connection there so that we can see that on the outside, and I'll remove the one that was already there, and then I'll expose the condition to the outside world like so. Close this up, double click, and now I've got the condition. You can see it's not doing anything now. Essentially it's muted, or now it's unmuted. Oh, I have to reconnect it like so. There we go. So now if it's connected, or if it's checked rather, we get the mute condition, or we get the unmuted condition. And if it's unmuted, unchecked, then our tool doesn't work. Well, what if instead of making this a mute button, what if I actually wanted to have a completely different behavior inside of there? All right, well, let's do that. Let's copy and paste. Just going to select all those nodes, do a Control-C, Control-V, just like you would in a word processor. Let's go ahead and pipe now this into the false statement, or the unchecked statement. Well, what could I do that's a bit different? Right now we're pushing all of the normals in the same, same basic direction, or this being multiplied by the same value. What if I put a little variance in there? Let's get just a straight up multiply node, and I'm going to pipe that into the output of the normals. So now I can take the output, the XYZ value, and multiply each one of those channels by any value that I like. So for instance, if I put a 2 in Y, now I'm going to have essentially a push that has twice the influence in Y as it does in X and Z. So it's kind of a tall push. We could make this, go in here and say, all right, well, I want it to be super tall. So just a little bit in X and Z, but quite a bit in Y there. So now we get a push that looks something like that. Expose all this to the outside world. All right, so we want to get our slider, of course, our factor slider, and then we want to get our vector, our XYZ value for the multiplication. Now if I leave the compound, check it out, I've got a much bigger, well, not much bigger, but I got a few more parameters on our dialog. Right now these aren't making much sense, so I could go in here and rename any of these. Let's just rename the condition here to, well, we could call it mute, or toggle, whatever you want to call that, and it'll update there in the property page and also as the input. Now what's cool about these inputs is everything here I'm doing with a slider. What if I wanted to control this with another compound? I've already created this compound. This is a tool that somebody else could use. Well, let's use a tool that someone else made for my compound here. So I'm going to grab a turbulence around value, and this outputs turbulence. Right now I'm driving every single one of the vertices with this one slider. So every vertex is getting the same multiplication factor. If I use a node like this, which really isn't anything special, just a common node, if I plug that in, now that slider gets overwritten and each vertex gets its own unique value. So here I'll turn that on in just a second, but here I can increase the scale, the variance of my turbulence. If I click on animate, check it out. Now I've got this kind of a wobble flubber stuff going on there, something like that. Increase or decrease the size of that, pretty neat. And then of course I can always go and do my checkbox here, turn that on or off. Now it's neat about, I mentioned if I unconnect this, I mentioned that this slider is driving all the vertices at once, or with a common value, but when I plug in turbulence, it's assigning to each vertex obviously a unique value. Look at that, 250 frames a second. Well, what if I want to control the condition on a per vertex basis? What if I don't want this to be a global toggle? Check this out. We have all these testers, we call them. So I'm going to do a test, and these are all the different things that you can test for inside of ICE as it comes from the box. You can certainly create your own. These are all just ones that were created in Montreal by our developers using the existing tools. So I'm going to do a test here. I want to do a test inside geometry. And you can see what that returns is an orange dot or a toggle, a yes, no, a boolean. So let's plug that into toggle. And now I need to give it some geometry to test to see if it's inside of. So I'm going to get a cube, and I'll just move this over here. And let's just press, well, I want to get the cube into ICE. The easiest way to get a parameter into ICE from a piece of geometry is just press F3. That'll open up a floating Explorer view, and here I can drag in any parameter. I could drag in, if I just want to drag in the position of that guy. So this now represents the position of the cube in space. What if I just want to get the actual object? Press F3, grab the object name, drag it in, and now this is now the nodal representation for this object. This purple dot is the value, the name of the cube. This is what this is asking for. Plug this in, and now check it out. If I move this across, let's go into wireframe. Check that out. How cool is that? Now only where the cube is inside, or the torus here is inside the cube, are we getting that that kind of funky wobbly deformation. And so you can see that it's working on a per vertice basis, and that's really one of the cool things about ICE. You can trigger an entire effect, by using a global switch like the toggle, or not having, just simply by not having a compound or a node driving each vertice separately. So again, very simple to do that kind of stuff. Control either the entire object or each individual vertice. Let's bring this thing into Maya. I want to show you how the cache system works, how we can get this animated piece of geometry to go right inside of Maya. So first, let's go and just set a couple keyframes. So we'll set a keyframe there at frame 1 for the position of the cube. We'll have the cube pass through the torus, set another keyframe, and that's essentially the animation that I want to pass over to Maya. Now, when we're working with particles inside of ICE, we have the one-click update. Unfortunately, that doesn't work for geometry caches, just for a few different reasons, but mostly just to get a little more control, so you can be very precise about what type of geometry is going across. I want to export this torus here. So what I'll do is go into ICE, and under my simulation menu here, I have the cache manager. So I'm going to go into the cache manager, and this is where I can read, write particle geometry caches, a number of different types of caches here. And we also have a bunch of different cache formats. I shouldn't say a bunch. We have our standard ICE cache, the point cache 2, and also the N cache. If we're going to export something into Maya, we're going to want to use N cache. So turn on N cache. I've already have my selection picked, but if I had come in here for the first time with the object that I want to export selected, just click on Add Selection. That's going to add this to the list of what to write out. This is the path that it's going to write the simulation to. Make sure to check that out, because this can change, and you want to make sure that you get the right path. And that's really basically it. Go ahead and click on Write Cache. That's going to dump this into Maya. I'm going to switch over into Maya really quick. There's our torus that we exported a while ago. Going to go to Geometry Cache, Import Cache. Oops, select the object first. Import Cache. And now it's going to look for that clip. And I think I've got it here under default. Go into simulation, and there's the cache it just wrote. Click on open and check it out. There's our cache. If I scrub the timeline, just the way we saw it inside of Softimage. So what's also cool here is this is a live link. So if I were to go and bring Softimage back up, let's go and remove the animated cube going through there like so. Let's just get rid of that. Let's bring back up our cache manager. Click on Write Cache, and if I go here to Maya, watch, the next time it updates, it's there. It's not animating anymore because I've got rid of that. So let's actually reverse this. Let's make this animate, because our condition was set to false. Turn that back on. So now we get our wobbly bit here, and let's write that out one more time. So I'll go ICE, Simulation, Cache Manager, and I'll press Write again. And look, before it can even finish writing, it's already started to modify the geometry on the Maya side. So it is a nice live cache. So that's pretty cool. So let's go ahead and just stop that. Let's go full screen back into Softimage. And you know what? Let's talk about particles for a while. So we've definitely discussed, get rid of that guy too. Definitely talked a bit about how deformers would work, how we could get those deformers into Maya. Now let's go and throw some particles on here. So with my wobbly thing selected, let's just keep working with this exact same effect we have going on here. So go into ICE, and this time I want to create a particle. So I'll do a basic emission, and what that'll do is just start sending particles flying off of my my animated wobbly emitter there. So let's just get rid of the grid, see that a little bit better. Now the particle. What that just did, by the way, the particle created the particle cloud node right there. So that's actually its own entity, and it built this ICE tree for me, which contains a simulation root. This is where I can plug in things to be executed, change colors, state colors, things like that. If I go into the actual emit geometry, you can see we've got a bunch of parameters here as well. If I double click on this, here's our property page with all of the parameters that correspond to our particle emitter. And you know what? The particle emitter is just another compound. You can dive into the particle emitter and see exactly how that's wired up, right down to the nitty-gritty of how those points are actually generated within the Softimage architecture. So it's a very open system as well, very expandable, flexible, etc. So anyway, let's go and let's tune some particles. So let's go here, and first, instead of 40 particles or 400 particles per second, let's make this like 40,000. Be because, well, we can. I want these to all go upwards. Right now they're all kind of going in their own sort of, well, they're going in the direction of the emitter's normal. So I'm going to change this to a directional vector. Whichever value here has a 1, that's which direction they're going to go. So now they're obviously going up in Y. And I'm going to go ahead and close this up. Now, what you can do, you can continue to work by pulling out nodes here from your list here, or if you go up to this pull down under ICE, we can do actually build the tree using these pull down menus as well. When this was new with 2011, so what I could do is say, you know, on emission, I want to set the particle age limit because right now the particles are living forever. So I'll click on Set Age Limit and press Control R to tidy up the ice tree there, and you can see it added this set particle age limit to the execute on emission input for our particle emitter. Set this to maybe like 0.3, and that's supposed to live for like 10 frames, but you can see the particles are still living forever. And the reason for that is I haven't told them that after they're emitted to delete them at their age limit. So you can see a bunch of other things that you can add here. I'm going to hit delete at age limit, pipe that in, and check it out. So now we've got our age limit there. So now if I change the actual age limit, you can see that the particles will definitely respect that value change. You know, let's do this. Let's get that same turbulence node that we used before, and I'm going to plug that into the age limit here, like so. And now you can see I've got turbulence on the age limit. I can increase that. I can animate that if I'd like. That's kind of a cool effect. We could put some type of force on here. I could add gravity, wind, neighboring forces. I could do it, the manual method too. I could just type in the word force, add forces. Forces, if you're working with particles, should go in the simulation route, although you can plug them in here as well into your main ice tree, your terminal node, which is this guy here. I'm just going to plug that into forces. Then I could add something like, just get your basic gravity, add that. And you can see now I've got gravity on those particles. Or you can use another node, just like turbulence. And this is something I want to show you here is if we get the turbulence around value node, look, these both have green dots, which is a scalar output, a single digit. But the forces is looking for a vector, an XYZ value, right? So I'm just going to take this and watch what happens. I'm going to double click this. Watch what happens to this property page when I plug this green dot into a yellow input. Boink. All of those automatically got changed to vectors. So a lot of the nodes inside of Softimage ICE will do what we call automatic data typing, where they'll automatically convert to whichever the whatever the proper data type that you're looking for is, or whatever the system needs. So let's go ahead and tune these a little bit. Maybe we'll get rid of some of the X and the Z variants. Maybe give them like a little bit of initial Y to get them moving upwards. I don't know, something like that. I could animate the turbulence there as well. It's starting to look, I don't know, it's almost like a fire effect. Well, here, let's just do this. Let's get fire. I have this cool fire color compound that I've already already made. And what that does, it essentially just turns the particles to the color of, I kind of try to simulate some fire. So this is cool. We've got an animated emitter being driven by ice. We got some particles coming off of there. Let's get all this into Maya. Not a problem. And again, you can do the same thing with Max. I just happen to have Maya loaded. I'm just going to push the update button. So you don't have to hit stop, but I'm just going to press stop. Click on update, and what this is now doing is caching this particle effect to disk. And if we toggle back into Maya in just a second, as soon as it's finished, there we go. Pop into Maya and check it out. There's our particles. And if I go to smooth shading and press play, there we go. You can see our particles are nice. There we go. Select the sky. See the colors are adhering as well. Everything's good, and there you go. So it's very easy to get your particle simulation, your geometry. Check that out. I've got my deformed geometry on there. I got my particles coming out. Let me go back in here and just hit stop really quick. There we go. So cool little interop between Soft and Maya. Very easy to do that. Let me show you a few other things here while we're working with particles. Gonna press play. These are, obviously particles, individual elements. We have this thing called strands. There's this whole strand framework which allow you to, well, think of strands as like a trail that a particle would leave behind, sort of. I can drag this node in, generate trail strands, or strand trails rather, and if I plug this into my simulation route, now check it out, tidy all this up. We're emitting these strands. I'm going to go and just turn down the number of segments because it's getting a little slow there. I've got a lot of particles and a lot of segments. And there we go. And also let's just turn down the number of particles because we're generating just a crazy amount of strands at the moment. There we go. And there you go. So now we've got some of these cool little strand effects happening, which that may not be enough. This, oh, you know, actually, here, let's do this. We can increase kind of the thickness. There we go. So it appears a bit darker by using the strand multiplier. There we go. So that's pretty cool. Shoot, let's put a little more turbulence on there. Let's make these things get a little bit more crazy. So under the forces here, let's really crank these guys up, and you can see exactly, where all those strands are going like that. Pretty cool. So strands are neato, and there's actually a different type of strands. These are actually just being emitted from the where the particles were. If I select my geometry here and go ice, let's go create. I'm sorry, ice create, and then dynamic strands. Check this out. And press play. So now I've got two types of strands going on. And these strands behave more like, almost kind of like hair, if you will. You can tune these as much as you'd like. I'm going to set this up to be like 400 of these strands, and maybe we'll decrease the number of segments a bit and increase their length. So now they're a bit longer. If we go down here, we got strand force, strand gravity, actually some other controls here for the strands. I'll maybe set the stiffness to like 0.3 and check it out. Now we've got some kind of funky hair. If I select the torus, well, what's left of the torus, look, I can move that all around, and look, the strands are just behaving nicely. Isn't that amazing? Just how fast that is. We've got a multi-threaded deformer going on. We've got strands coming out at the top here. We got some other strands going out the bottom, and you can see they're definitely following the emitter around. Wherever I move that emitter to, those strands are moving. I could glue the strands to there as well, just like we see with the green example. Watch this. If I duplicate the torus, our wobbly thing here, now we have two animated objects. What if I want this to be an obstacle? Check this out. Hold down the F3 key, or just push the F3 key. Drag the new torus into our ice tree. And look, in this strand dynamic framework is an input for a geometry obstacle. So plug that in and check it out. Now I've got an obstacle like that. The cool thing about ice is it's just so fast. It's so fun to just experiment. I really didn't know what to show you all today. I wanted to show you something, kind of build something from scratch. We wanted to get some stuff into Maya. I wanted to show you how things can interact with one another. You know, we've got two animated objects. Watch how the hairs are following that animation. You know, every frame it's evaluating what it's supposed to do. All of this stuff can easily go into Maya, like we saw. The strands aren't supported by Maya, but that's just a technicality, something you could extend yourself if you wanted to. But anyway, cool stuff, and we still have a frame rate of, where were we at there a minute ago? 50 frames a second, 30 frames a second. So we're moving pretty well there. So some cool stuff. So that was just a little bit of an introduction on how you get up to speed in ICE, some of the commands and stuff in there. And I'm going to show you a few other examples, show you a few other completed scenes of some other interesting work. So yeah, well, we have a few more minutes left. Let me show you a couple more examples, and we'll call it a wrap. So this is an interesting scene that I built sitting on an airplane one day, and really all I do here is I take a character, I create some particles with them with a 0 velocity, so they all stick to them, and I could make this like 10,000 if I want. And if I press play again, it'll re-simulate that, regenerate all those things. So you can see it kind of makes these little tiles. I've got a simple node on here to align to the surface of the man so that they actually are billboards that accurately stick on them. And then I'm using the state machine. I haven't talked about state machines, but states just allow you to have a trigger. Just like we had the tester before, test inside of a geometry here. I'm testing to see if it's inside this cube. And if the particles do fall in the cube, they move from state 1 to the next state. And the next state gives them gravity. So here, as soon as they go into the pink state, if you will, each state gets color-coded so you can see it easier, they begin to fall. And then after a random amount of time, they'll go to the next state. And the next state has them form into this elephant, which, I don't know, the only 2 models I had on the plane that day. But anyway, you can see we have a bunch of different states. Test if inside the null. If it is, then it moves towards the goal. And the goal is going to be whatever the goal might be. In that case, it's the elephant. And then I made it actually just do a kind of a cycle so that when they're the elephant, they test that or detect that they're inside that cube. Then they're going to go and form the man again. So it really makes this complete, total looping cycle of particle animation. So kind of weird, kind of interesting, just to kind of show you some of the workflow we have with states. Very simple to set up. You have a state, you have a trigger. It's either in the state or it's leaving the state, going to the next state. So pretty cool. Let's look at something else real quick. Yeah, so this next scene is well, it's kind of a cool little sink scene. A sink scene, yes, a sink scene. So here we've got some geometry, some utensils, a little cup there, a little coffee pot, potato masher, of course. And this actually all started off in Maya. Most of this did at least, and then just did the one button send to Softimage. That emitter actually was created inside Maya, the P cylinder. Sent that all over to Soft, created a little bit more geometry for the rest of the kitchen, and just turned Lagoa loose on it, and bam, check it out. A neat little simulation of our sink spewing out some liquid. I'll let this play back in just a second, but just want to show you something, well, a couple things cool here. One, gonna select the geometry, and of course any ice simulation, any particle simulation, you can turn that into real geometry if you like, something like this here, and you can increase the detail or the ISO level. There's some other tools there that we've seen in some other videos to tune that even further, but you can get some cool looking effects. You can render all that out, of course. Another thing that's pretty neato here is I've set this up to have a stereo camera, so if you have some anaglyph glasses, pop those on, and this starts to look even neater as these little particles flow out in 3D. But for the rest of us, we'll go back to a regular camera. And just, check out the cool collision detection in here. You got the cups. Let's just go and hide this guy right here, and you can see that it's leaving that nice perfect space where it was. Ooh, the water kicks back on. The light blue particles, by the way, are the ones that are moving slow. The darker blue ones are faster moving particles, and you can see they're filling up the coffee cup, or the coffee pot rather. Let's just grab this, pause it real quick, and just check this out. Like, you can get right in the. Let's back up a bit. Look at that. It just makes a nice little hollowed out spot, and you can see the fast moving particles just engulf it. And then it's covered up. And I let this simulate, I think, for about 2 days to fill this up. But you can see, the particles never disappear. They're just accumulating. So this is just massive. And until the particles finally flow across. So pretty cool, huh? Just more fun with Lagoa. And let's see what else I can show you. All right, well, I bet you weren't expecting to see this. I'm going to press play, and hey, check it out, Space Invaders. I was saying that ICE is a programming language, so shoot, one of our lead engineers program Space Invaders, complete with a scoreboard, listen, sound effects. Look at that. All through the power of ICE. Have you ever seen Space Invaders like that? Didn't think so. Check that out. Weird, huh? You can even play like this still. If we just go ahead and stop that, check it out. I'll go to wireframe. I've got my viewport set to black, but so you get a little darker background there. But it's all done through ICE. Every single one of these compounds here is controlling a certain part of the animation, a certain part of the game. And I don't think Atari initially programmed Space Invaders quite like this. So, there's just so many things you can do with ICE. I showed you that ray tracer earlier. Check this out. I'm going to show you something else. All right, so we're just about out of time, so I think I'll show you one more quick example. This one here is also from Paul Smith, and I showed you the earlier ray tracer with using particle strands. This is a different approach. Here, what Paul did is took a mesh, made it crazy dense, and actually samples the vertex colors by shooting rays through this basically flat grid, and then it inherits the texture color behind it. But look at all the neat stuff that he can do. He's got shadows turned on. There's a light source. This object here is acting like a light source. And look, if you move your light around or move the timeline, see the way the shadow shifts? Check that out. Doink, as it essentially renders that. He's also got reflections on here. Look, I turn reflections on. We can turn on depth of field. Crazy. All done through ICE. So I can actually let Paul explain that to you on his Vimeo site. If I just pop up good old YouTube here real quick, if you just do a Google for Paul Smith. Paul Smith. Well, I guess I was a little optimistic to think that there would only be one Paul Smith in the world. Let's go Paul Smith Vimeo. There we go. That's better. So here is a bunch of his videos. I'm just mentioning this for training purposes. Lots of good training stuff out there. I was actually watching this ray tracing scene kind of progress and figured I'd finally email him and see if he would let me borrow it. So there's also that little zombie thing I showed you at the beginning. There's a whole bunch of tutorials on how all that was done. So kudos to Paul for his awesome work. There's an explanation of how the ray cam works, far more than what I'll do. If you just do a search for Softimage ICE inside of Vimeo, you'll find all sorts of stuff. I mean, there's shoot, I don't know, 1,000 videos just alone. This is cool. Exocortex, the guys that did Slipstream, they've also released now Momentum 2.0, which is another physics solver. It's based on the Bullet real-time physics engine, so very cool stuff there. You might want to take a look at that. Just go to exocortex.com. And then, all sorts of other stuff in here. Just cool demos, cool tutorials, because there is just so much that ICE can do. I mean, I've tried to figure out what I could show you in 45 minutes. Here's some hair development based on Strands. Sci-Flex cloth has been completely updated for Softimage 2012 to take full advantage of ICE. So if you've used a Sci-Flex before, you're going to notice a huge increase in performance if you're using a fancy multi-threaded workstation like this HP I'm using right now is. So all sorts of good stuff there. Other training, digital tutors, they've got lots of stuff for Softimage. Softimage, the full animation tools as well as ICE. i3D, they've got some great tutorials. There's the Softimage channel on YouTube. There's my YouTube channel, which has some rendered stuff and some older webinars and things on there. So lots of good training available out there. Again, check out Vimeo, check out Digital Tutors, check all that stuff out. Thanks to Paul for hooking me up. And with that, I'm going to wrap up today's webinar. Hope it was somewhat enjoyable. Really had a whole lot to show you, and hope we got it all covered. So make sure to check out the Planet Softimage blog at thearea.com for any updates in the world of Softimage as well. So thanks a bunch, and we'll see you next time.